All right, chapter 14, we are continuing to dive into physics, and we've really talked about, so far we've talked about forces, we've talked about speed and velocity and acceleration, and we've talked about pressure. Well, our next kind of idea is going to be work. All right, now what the heck is work? Now, what do you define work as? Work is okay. I gotta go pick rocks in the field. I gotta go do the laundry. I may have to actually go to work. I all right, my parents go to work. Now that's not quite the definition from a physics standpoint. I don't necessarily just go to work from a physics standpoint. So something to think about there is what is work from a physics standpoint? Well, work is the following. Work is when you apply a force to an object and move it a distance. So work is when you apply force to an object and move it a distance. If you are not moving at a distance, you are doing zero work. So think about it this way. If you try and push against a wall and knock the wall over, you are going to exert a lot of muscle energy. But from a physics standpoint, you are doing no work because the wall is not moving. No motion, no work. That's the key thing. When you do work, something has to move. So if we take a look at work, we're going to get an equation for work. That equation is work is equal to force times distance. So work is equal to force times distance. Now, what is force in? Newtons. What is our distance in? Typically meters. Our unit for work is a Newton meter, or what we call a joule. A joule. So work is equal to force times distance. If we're doing our little triangle here, work is equal to force times distance. Work is in joules. Force is in newtons. Distance, we prefer to be in meters, and it has to be in meters, guys. So if you're getting a distance and it's in centimeters or millimeters, you're going to have to convert to meters. All right, kind of keep that in mind there. So work, let's review work. A couple of key things with work. You have to have motion, number one. Secondly, it's force times distance. Your motion has to be in meters, and your unit for work is a joule. So a couple things about work. Now, work can be done at a rate. All right, a rate is how fast something is going on. So power is how fast we are doing work. You can move something very slowly, or you can move something very quickly. Typically, if you move it quickly, is it going to take a lot of power? Yeah. All right, football players, think about moving the football sled. The faster you move the sled, typically, the more power that takes. So power is how fast you are doing work. The faster you do it, the more work you require. Right? Power is equal to work divided by time. Now we're introducing a couple more units here. What is the unit for work that we just got done off of the last slide? It's a joule. What's our base unit for time? I'll give you a hint. It's the smallest unit of time that we use, so it's second. The unit for power is joules per second. Now we have a new unit for power, and it's called a watt. Right? Its abbreviation is just a W. Don't get watt, the unit watt, confused with work. Okay? They're two different things. Watt is a unit, work is what we're solving for. So, work is in joules, power is in watts. So, if we do the circle for power, which also, I guess, we capitalize P even though that's pressure, is equal to work divided by time. Right? So power is equal to work divided by time. Power is equal to watts. Work is equal to joules. Power, the faster you do something, the more work it requires. All right. So, in review real quick, we have two major things. We have work and power. Work is force divided by, work is force times time. Work is, oh my gosh, let me start over. Work is equal to force times distance. Its unit is a joule. Power is equal to work divided by time. Its unit is a watt. For work to happen, you have to have something in motion. Power is how fast you're doing work. The faster you move something, the more work it takes. That is the end of section 14.1. This is Mr. Clark. I'll see you later.